Hello students, welcome to my class. In today's class, we will continue with the chapter Triangles of class 10. We were doing exercise 6.2 and in that we have completed 7 questions. The remaining questions we will discuss today. So question number 8. Using theorem 6.2, prove that the line joining the midpoints of any two sides of a triangle is parallel to the third side. So this is question number 8. So here theorem 6.2. So theorem 6.2 is actually converse of basic proportionality theorem. So we have to use converse of basic proportionality theorem to prove this question. Okay. So what is given? Line joining the midpoints of any two sides of a triangle. So we will draw a triangle ABC. We'll consider a triangle ABC. And here we have to take the midpoint of two sides. So we will denote the midpoint of side AB as D and the side AC as E. Then the line joining the midpoint of two sides of a triangle, that is the line DE, is parallel to the third side. So this is what we have to prove. We have to prove DE is parallel to BC. What is the condition given? The points D and E are midpoint of the sides AB and AC. So this condition is given. We have to prove DE is parallel to BC. So we will see how to prove this. First we will write given ABC is a triangle in which D and E are midpoints of the sides AB and AC. So this is the condition. This is what given in the question. Now we have to prove. We have to prove the line DE is parallel to BC. So this is what we have to prove, and we have already studied whenever we want to prove two lines are parallel, we have to use the converse of basic proportionality theorem. Now we will see the proof. How to prove this? Proof we will see. It is given that the points D and E are midpoints of the sides. Okay, so we will start with that condition. Since D and E are midpoints of AB and AC, what we can write? Since D is the midpoint, what is its meaning? This distance, that is AD and BD are equal. So since D is the midpoint of AB, we can write AD is equal to DB. We will take this DB to the left side. So we can write AD by DB is equal to 1. So this is the first equation. Similarly, since E is the midpoint of side AC, same way we can say that the distance AE and EC are equal. So we can write, since E is the midpoint of AC, we can write AE is equal to EC. The same way we can take EC to the left side. So we will get AE by EC is equal to 1. So this is the second equation. Now if you see equation 1 and 2, the right side is same. So what we can do, we can equate the left side. So from equation 1 and 2, we can write AD by DB is equal to AE by EC. So we got this condition. What is the condition we got? AD by DB is equal to AE by EC. So this is actually converse of basic proportionality theorem. In a triangle, if D and E are points on the sides AB and AC, and it satisfies the condition AD by DB is equal to AE by EC, then by the converse of basic proportionality theorem, we can say that the line DE is parallel to BC. So we can write, therefore, by converse of basic proportionality theorem, DE is parallel to BC by converse of BPT. So this is how we have to prove. Now we will see the next question. Question number 9. ABCD is a trapezium in which AB is parallel to DC and its diagonals intersect each other at point O. Show that AO by BO is equal to CO by DO. So this is the question. So here what is given? ABCD is a trapezium with the sides AB and DC are parallel sides. So first we will draw the diagram. We will draw the diagram. ABCD is a trapezium. ABCD is the trapezium where the side AB is parallel to DC and its diagonals intersect each other at point O. So we will draw the diagonals BD and AC. Diagonal BD and AC intersect at the point O. Then we have to show that AO by CO is equal to AO by BO is equal to CO by DO. So this is what this condition we have to prove. So what is given? We have a trapezium ABCD in which the diagonals intersect at O. We have to prove this condition. So we will see how to prove this. First we will write given. So ABCD is a trapezium. ABCD is a trapezium with diagonals AC and BD intersect at O. These two diagonals intersecting at the point O. Now what we have to prove? What is the condition we have to prove? AO by BO is equal to CO by DO. This is what we have to prove. So for proving this, we need to do a construction. That is, we have to draw a line EO. So this point we will denote as E. We have to draw a line EO parallel to AB. So this is the construction. So we will write construction, draw EO parallel to AB. Now you see here, we will consider, now we will see the proof. So we will consider the triangle ADB. First we will consider this triangle ADB. So in this triangle, if you see, the line EO is parallel to AB. So as per our construction, we have this condition. EO is parallel to AB. Since parallel condition is there, we can apply basic proportionality theorem. So we can write in triangle ADB, EO is parallel to AB, therefore by basic proportionality theorem, in this triangle what we can write? DE by EA is equal to DO by BO. So we can write DE by EA is equal to DO by BO. So this is the first equation. Now you see here, since this EO is parallel to AB, EO is parallel to AB and it is given in the question AB is parallel to DC. So from these two conditions, what we can say? EO is parallel to DC also. We will get this condition. Okay, so EO is parallel to AB as per our construction and AB is parallel to DC. This condition is given in the question. So from these two conditions, we can say that EO is parallel to DC. So we will consider now the triangle ADC. Next we are going to consider this triangle, that is triangle ADC. So this triangle we are going to consider, and for this triangle we will apply basic proportionality theorem. So by again in triangle ADC, since EO is parallel to DC because of this condition, okay, EO is parallel to DC, again by basic proportionality theorem we can write, what we can write? DE by EA is equal to CO by AO. So So this is the second equation. Okay. So using basic proportionality theorem, we got these two conditions. Now you check equation 1 and 2. The left side expression is same. So both the equations have same left side expression. So we can equate to the right side. So we can write therefore from 1 and 2. From equation 1 and 2, what we can write? DO by BO is equal to CO by AO. Actually what we want? AO by BO. So we will do this thing. This we will take this AO to the left side and DO to the right side. So we can write AO by BO is equal to CO by DO. Actually this is what we have to prove. Now we will see the next question. Question number 10. The diagonals of a quadrilateral ABCD intersect each other at the point O such that AO by BO is equal to CO by DO. Show that ABCD is a trapezium. So this is the question. So here we have a quadrilateral ABCD in which the diagonals intersect at the point O, and this condition is also given. AO by BO is equal to CO by DO. We have to show that the quadrilateral is a trapezium. So first we will draw the quadrilateral ABCD. ABCD is the quadrilateral and in which the diagonals intersect at the point O. Diagonals intersect at the point O, and we have to prove that this quadrilateral ABCD is a trapezium. So for proving a quadrilateral is a trapezium, what is the condition we need to prove? We have to prove any one pair of opposite sides are parallel. So we have to prove AB is parallel to CD. So if we are able to prove one pair of opposite sides are parallel, then we can say that ABCD is a trapezium. So for proving this, we are going to do a construction, that is EO. EO is the construction. Draw the line EO parallel to AB. So this construction we are going to do for proving this question. So first we will write given ABCD is a quadrilateral with diagonals AC and BD intersected to O, and this condition such that, what is the condition given in the question? AO by BO is equal to CO by DO. So from this condition we can write this CO, we will bring to this side. Okay, so we will get the condition AO by CO is equal to BO by DO. So this condition is given in the question. Now to prove, what we have to prove? ABCD is a trapezium. We have to prove ABCD is a trapezium. What is the construction? Draw OE perpendicular to AB. So this is the condition. Now you see here, since the line OE is parallel to AB, we will consider this triangle ADB, and here in this triangle we can apply basic proportionality theorem. So we'll see the proof now. In triangle ADB, since OE is parallel to AB, by basic proportionality theorem, we can write AE by ED is equal to BO by DO. So this is the equation. Okay, so this we will name as equation number 1. Now you see here, what is the condition given in the question? BO by DO is equal to AO by CO. So what is equation number 1? Right side we have BO by DO. So in equation number 1, instead of this BO by DO, we will write this value. So in equation, from equation number 1, we can write AE by ED is equal to AE by ED is equal to, instead of this BO by DO, what we can write? AO by CO. Now you see here, AE by ED is equal to AO by CO. So we have to consider now this triangle. So in triangle ADC, we got this condition, that is AE by ED is equal to AO by CO. So in a triangle, if this condition is satisfied by the converse of basic proportionality theorem, what we can say? This line EO is parallel to CD. Okay, therefore by converse of basic proportionality theorem, we can write EO is parallel to DC. Okay, so we have EO is parallel to AB. So this condition we have as per our construction. We have EO is parallel to AB, and now we got EO is parallel to DC. So we will name this as equation number 2 and this as equation number 3. This is as per our construction. Okay, this we will name as equation number 3. So now if you see equation 2 and 3, EO is parallel to DC and EO is parallel to AB. So from these two equations, what we can say? This line AB and DC are parallel. So AB is parallel to DC. So we got this condition, that is in a quadrilateral ABCD, we got the side AB is parallel to DC. So we can say that ABCD is a trapezium. So we can write ABCD is a trapezium. So ABCD is a trapezium. So this is how you have to prove. So today we have completed exercise 6.2, which is based on basic proportionality theorem and its converse. In the next video we will learn a new concept. If you like my channel, you can share and subscribe. Your subscription, my motivation. Thank you, students.